This unit is going to start basically our graphing unit. It's pretty long, it's got a lot of sections in it. There's a lot of new vocabulary that we need to talk about first. So I want you to actually just kind of make up a pattern of numbers. So for example, I'll start off with 2, 4, 6. And maybe you can guess the next number would be 8, and then 10, and then 12. And you would go on forever and ever and ever. So what we're going to do is we're going to learn how to show a pattern that never has an end, but we're going to learn how to show it on a coordinate plane. So some of this you've heard of before and other pieces you might not have. So we're going to write that the coordinate plane is a graph consisting of an infinite amount of points. So if you think about a coordinate plane, looks like that, and you would have tick marks here to show your grid. Well, if you think about it, your tick marks, you could keep adding another one and go on forever and ever. So we say that there's an infinite amount of spots on a coordinate plane. You've seen a point before. It looks like this, say 3, 2. So you've seen this before, and I know in my class, because I have assigned things like this before. I want you to remember, though, points are called ordered pairs. Or coordinates. So we can call points ordered pairs or coordinates, and they are written in the following way. You have pair of parentheses, first number, comma, second number. So the first number we call our x-coordinate. So 3 is our x-coordinate. And the second number we call our y-coordinate. And those two numbers tell you either to move left or right or up or down, which will give you a place to go in the coordinate plane. In order to graph an ordered pair, the first number means you move left or right. Where the second number means move up or down. So if you remember, when you plot a point on a coordinate plane, you move this way, left or right first, and then you move up or down. Now, if you have positive numbers, that means you're either going to be moving up or to the right. So I kind of want you to remember that up and right are positive directions, where down and left are the negative directions. So if you get a negative number, you're traveling either down or left. So go ahead and flip to the next page. We're going to label a coordinate plane. So this whole picture right here is what we call the coordinate plane. We're going to start with our x-axis and our y-axis. And the way I remember this is y to the sky. So that way you always know the y-axis is the middle line that goes up and down, where the x-axis is the middle line that goes left and right. So think of y goes to the sky. We call the dead center of the graph, right here, we call that the origin. And the coordinates of our origin will always be 0, 0. Now the top right quadrant is quadrant 1. And from quadrant 1, we actually travel counterclockwise. So the next quadrant, quadrant 2, will be in the top left. Quadrant 3 is in the bottom left. And quadrant 4 is in the bottom right. Notice that we write quadrants with Roman numerals. That's typically the way that we show them. We don't just write the number 1, 2, 3, and 4 usually. So you'll just see these a lot more often. So you want to be able to name all the parts of a coordinate plane. That's key to graphing. Go ahead and flip it over to the next page. We'll talk about some vocab words. So first things first, write X and Y in your 2 circles. You're going to hear some words besides X and Y, and you need to know which letter these words indicate. So the first word is input. The word opposite of that is output. Sometimes you'll see domain, and other times you see range. You might see independent, and dependent. And sometimes you'll see them actually use the letter X, but they'll use F parentheses X. And this is going to be really weird, but that F parentheses X actually refers to the letter Y. It's a kind of notation that we'll learn about a little bit later. So it doesn't mean F times X, it means Y. It means the output of a function, the output of a problem. So I might say, what's the domain? That means, what are the X values? I may say, what are the independent coordinates? So you would say the X coordinates. I might say, what's the range? Meaning, what's the Y coordinates? What's the dependent variable? What's the Y variable? I might say, find the output. That means find the Y's. So we kind of need to know that these words all flow together. And these words all flow together. And we need to know which letter goes with which words. Flip your packet over to the last page. Our first rule is that when we have a set of ordered pairs, it's called a relation. So what will happen is you'll be given a group of coordinates, and we use these little braces to show the group. Those little squiggly lines, they're called braces, and they mean a group or a set. So there is a set of coordinates or ordered pairs. That whole set, this whole thing, we call a relation. Now there are 4 ways that you can show a relation. The first one is what you see in the example. I could actually just write out all the coordinates. 2, 3, -1, 0, and 5, 6. Another way you can list these is you can just write them going down. Just like that. So that's one way to show a relation. A second way is what we call mapping. And what you do first is you draw 2 ovals. and we put the letters X and Y up top, or I might use D for domain and R for range. Again, just because we learned like domain means X, range means Y, so I can change those out if I would like. And you're just going to make a list of all your X coordinates. So those would be all the first numbers in the ordered pairs. So 2, -1, 5. So then all the Y coordinates would be 3, 0, and 6. And I'm actually going to prove a point here that order does not matter. So I chose to write 3, 6, 0. And that's okay. I can change up the order however I feel. It's not going to mess anything up. And then you want to connect the correct points to their matches. So 2, 3 was a point, so they get connected. -1, 0. That was a point, so they get connected. And 5, 6. Now, if I had done this differently and I changed the order to, let's say, I still had 2, -1, 5. Let's say someone else decided to use 3, 0, 6. Well, then their map would look like this. But both of these are correct. What I look for is if you have like 2 matching up with 3, and it does in both problems. So that's what I need to see. And with a map, we never write the same number twice. So if I added the coordinate, let's say 0, 6, I would put 0 in here, but I would not write 6 again. I would simply just connect 0 to 6, so there will actually be 2 lines coming out of 6. So you never want to repeat a number in a circle. Just keep aware of that. You can show a relation by making a table. So you can put all your X coordinates in the table, and then you put their matches in the Y side. So you'll always see X or Y, or sometimes you'll see X and then F parenthesis X. We can switch them on and off if we want. And that's really it. And then the last way to show a relation is by actually graphing points. So if I want to graph 2, 3, I go over 2 and up 3. Now graph -1, 0. Since it's negative, we go left 1 and up none. And then the last point is 5, 6. We simply go over 5 to the right and up to 6, since they're both positive. And you don't need to connect these. You can just leave them as is, and that's fine. But what's important for you to realize is I could give you a map and ask you to show me the relation as a graph and as a table. Or maybe I'll give you a table. You have to show me the map and the graph and the ordered pairs. Or I might give you a graph, and I might tell you to map, show the relation in the table, and show the relation as ordered pairs. So as long as you know one of these 4 pieces, you can make the other 3 happen.